the definition of Jacobian. So x is suppose function of u and v, and y is a function of u and r. Then JUV is dabba x by dabba u. X and y are the functions of u and v. Dabba x by dabba u, dabba x by dabba v, dabba y by dabba u, dabba. Here right, y is function of u and v. Here is a correction. The x and y both are function of u and v. Then Jacobian of Jacobian UV, or is also denoted by dabba UV, dabba XY, dabba UV. This is the notation, and is dabba x by dabba u, dabba x by dabba v, dabba y by dabba u, dabba y by dabba v, and this determinant is this. So already this is the another notation, dabba UV, J UV, or dabba XY, dabba UV. So both are the notations are same, and the value of this quantity, that is Jacobian, is this. If x is r cos theta and y is r sin theta, we know that these are the polar coordinates. Then Jacobian is what? Is dabba j r theta. The notation is what? Capital J or j r theta is dabba xy, dabba r theta. Here the x is function of u, x and y are the function of u and v. Here the function x and y are the function of r and theta, and therefore the notation is dabba capital J r theta is the notation instead of this j u v. Dabba xy, dabba r theta. This is the notation, and is equal to determinant dabba x by dabba r, dabba x by dabba theta, dabba x by dabba r, dabba x by dabba theta. This first row, and the second row is dabba y by dabba r, dabba y by dabba theta. And then dabba x by dabba r is this. The derivative is what? Cos theta. Similarly, this is dabba x by dabba theta is r is constant. Derivative of cos theta is minus sin theta. Similarly, dabba y by dabba r is sin theta, and dabba y by dabba theta is r cos theta. And then this into this, r cos square theta minus minus become plus r sin square theta, and then take r, here is r notation, then take r as a common, then cos square theta plus sin square theta is 1. So Jacobian is r. If x is r cos theta and y is r sin theta, then its Jacobian is r. The Jacobian of coordinate transformation. Suppose x is UVW and y is UVW, and z is KUVW. That is x, y, z are the functions of UVW. Then the Jacobian UVW is equal to Jacobian UVW is equal to dabba xyz dabba UVW. This is the notation, Jacobian UVW, dabba xyz dabba UVW. And is what? Dabba x by dabba u, dabba x by dabba v, dabba x by dabba w is the first row. Then dabba y by dabba u, dabba y by dabba v, dabba y by dabba w is the second row. And the third row is dabba z by dabba u, dabba z by dabba v, dabba z by dabba w. Suppose x is, these are the cylindrical coordinate. X is r cos theta, y is r sin theta, z is equal to z. It's all the cylindrical coordinates. Then Jacobian is what? J r theta z is dabba xyz dabba r theta comma z. Is what? Dabba r by dabba x by dabba r, dabba x by dabba theta, dabba x by dabba z is the first row. Then dabba y by dabba r, dabba y by dabba theta, dabba y by dabba z is the second row. Similarly, dabba z by dabba r, dabba z by dabba theta, dabba z by dabba z is the third row. And then dabba x by dabba r is cos theta, dabba x by dabba theta is minus r sin theta, dabba x by dabba z. With respect to z derivative, this x is a function of r and theta, and therefore derivative 0. Similarly, dabba y by dabba r, dabba y by dabba theta, dabba y by dabba z are these. And then dabba z by dabba r, dabba z by dabba r is 0. Then dabba z by dabba theta is also 0, and dabba z by dabba z is 1, right here 1. Dabba z by dabba right here 1. And then its determinant cos theta in bracket this into this, that is r cos theta into 1 is r cos theta minus 0, then plus this minus minus plus, so this is plus r sin theta in bracket sin theta into 1 is sin theta minus 0, and the last is 0 in bracket 0 minus 0. So we have r cos square theta plus r sin square theta, take r as common, cos square theta plus sin square theta as r. That is these are the cylindrical coordinate. Then Jacobian is also r. If the polar coordinate, Jacobian is r. For cylindrical coordinate, Jacobian is r. Find Jacobian deva xy deva uv for the transformation. X is equal to u cos v, y is equal to u sin v, and x are this. So first example x. So Jacobian deva xy deva uv is what? Deva x by deva u, deva x by deva v is the first row, and then deva y by deva u, deva y by deva v is the second row, and then deva x by deva u with respect to u derivative is cos u, then deva x by deva v is minus u sin v. Similarly, deva y by deva u is sin v, and then deva y by deva v is u cos v, and then this into this u cos square v minus minus become plus u sin square v, and then take u as common, cos square v plus sin square v is 1. X is u sin v and y is u cos v. Then again, this is the answer. So solve the system. X is equal to x minus y, v is twice x plus y for x and y, in terms of u. Then find the Jacobian deva xy deva uv. So first find the values of x and y in terms of u and v. So u is this, v is this, and then we have after solving, that is add subtract. Subtracting these two, we have x is this, and that is add these two, we have the x is this, and if we subtract, if we multiply equation number 1 by 2, and then subtracting, we have this. So very simple. And then Jacobian deva xy deva uv is what? Deva x by deva u, deva x by deva v, deva y by deva u, deva y by deva v. That is the derivative with respect to u is 1 by 3. The derivative with respect to v is 1 by 3. The derivative with respect to u is minus 2 by 3. Deva y by deva u. And the derivative with respect to v is 1 by 3. And then 1 by 3 into 1 by 3 is 1 by 9. Minus minus become plus 2 by 9. That is 3 by 9. That is 1 by 3. Find Jacobian deva xyz deva uvw of the transformation. Xyz are given. So Jacobian deva xyz deva uvw is what? Deva x by deva u, deva x by deva v, deva x by deva w, deva y by deva u, deva y by deva v, deva y by deva w, the second row. And the third row is deva z by deva u, deva z by deva v, deva z by deva w. And substitute deva x by deva u is cos u, cos v. Deva x by deva v is u is constant, cos v derivative is minus sin v, so minus u sin v. And then deva x by deva w is 0. Similarly, write deva y by deva u is sin v, deva y by deva v is u cos v, and then deva y by deva w is 0. Then deva z by deva u is 0, deva z by deva v is 0, and deva z by deva w is 1. And now solve this determinant, we have the answer u. Similarly, Jacobian for the second example, this example, deva xyz deva uvw is again the same formula, and then deva x by deva u is 2, deva x by deva v is 0, deva x by deva w is 0, like that. Substitute all the values, we have the answer 3. U is this function of x and y, v is function of x and y for x and y in terms of u and v. Then find Jacobian deva xy deva uv. So first find the values of x and y in terms of u and v. So these are the values of x and y. And then Jacobian deva xy deva uv is what? Is this, that is determinant, and we have the answer 2 by 3. Then next example is example of change of variable. So in order to change the variable, we have to replace dx dy by mod j du dv. So u is this, v is this, and we have to evaluate this integration by changing the variable. So from this, find the values of x and y. So x is u plus v and y is 2u. So solving these two for u, x and y. So x is u plus v and y is 2u. And then we have to draw the first figure from this integration. So first draw this figure. So x is equal to y by 2 means y is 2x. Y is 2x is this figure. Then this is x is equal to y by 2 plus 1 means we have y is equal to 2x minus 2. This is the y equal to 2x minus 2. Already this problem is covered in the previous lecture. So y is equal to 2x minus 2. These two lines, y is equal to 2x and y is equal to 2x minus 2, both are parallel because their slopes are same. Y is equal to mx plus c. M is the slope, 2 is the slope, 2 is the slope. So these two lines are parallel, but this line y is equal to 2x minus 2 passes through the point 1, 0, and this point y is equal to 2x line passes through origin. Okay, so how we can draw the figure of the any straight line? If the constant term is 0, then the line passes through the origin. But if the constant term is not equal to 0, then how we can find its draw its graph? So substitute x as 0, y is minus 2, and substitute y as 0, then x is 1. So 0, 1. So this line passes through point 0, 1, and that another point is if we substitute x is 0, then y is minus 2. That is minus 2, 0 is this point. Okay, 0 minus 2, and then this is 1, 0 point. And another point, if you have to find another point, substitute x as 4, x as 4. So what do we have? X as 4, then y is what? 8 minus 2, that is 6. So 6, 4, 6. This point is 4, 6. So draw the figure. Then y is equal to x. This is the limit on now. Y is 0, means x axis, and y is equal to 4, means this line. Okay, so this is the region bounded by these 4 lines, and then this convert to this. Actually this is figure first, and then this figure is now second. That substitute x and y as this, x as u plus v, y as 2v in this. So we have u is equal to 1, that is this line y is equal to 2x minus 2 converted to this line u is equal to 1. Then substitute y as a 2v. 2v is 4, means v is 2. So v is 2, this line parallel to u axis, uv. And then y is equal to 2x. Substitute x as u plus v, y as 2v. So we have u is equal to 0. U is equal to 0. Substitute y is equal to 2x. Y is equal to 2x. So y is u plus v, and v is 2v. So we have u 2 into x, that is 2u plus 2v. That is we have u is equal to 0. Y is equal to 2x converted to u is equal to 0. And y is equal to 0 means v is 0. So this is reason G, and then R converted to G, and these all these lines 4 converted to these lines, and therefore double integration over this integration is equal to this integration is equal to replace in the integrand x as this u plus v and 2y as 2v. So simplify this. We have the answer u. We have the answer u. If you substitute these values, and then if you had to integrate, suppose v first, then take parallel strip to v axis. V take strip parallel to v axis. Then its one end touches to 0. V is equal to 0, and another end touches to v is equal to 2. So v is equal to 0 to 2 is the lower limit, upper limit. And in order to cover this region, we have to move the strip from this point to this point. So u is equal to 0 to u is equal to 1. So the value of this is, I think, 2u. So 2u, and value of mod j. Mod j is what? So find mod j. Find j for this. So mod j is what? J is daba xy, daba uv is a determinant. Like this, daba xy, this daba xy, j is daba xy, daba uv is what? Daba x by daba u, daba x by daba v, daba y by daba v. And then find its determinant. So find that Jacobian. So this is the formula. The double integration over r fx dx dy. This is the formula for change of variable. Is equal to double integration over g f of guv and huv. That is x and y replaced by x and y by in terms of u and v. and then dx dy is replaced by mod j du dv. So find mod j for this example, and then we have the answer for. Okay, so here is the, and that x is equal to this y by 2, x is equal to y by 2. Simplifying this, we have this u is equal to 0, that is x is equal to, that is y is equal to 2x, this line converted to u is equal to 0. Similarly, y is equal to, this is y is equal to 2x minus 2, this line converted to u is equal to 1, and y is equal to 0 converted to v is equal to 0, y is equal to 4 converted to v is equal to 2. So this is the table. So similar examples, the integration, double integration 0 to 1, 0 to 1 minus x, root x plus y, y minus 2x bracket square. Already this example is covered in the next, in the previous lecture, that is substitute u as x plus y, v as y minus 2x. And then find the values of x and y in terms of u, find Jacobian, and then draw this figure, and we have the answer 2 by 9. So polar coordinates. So x is equal to r cos theta and y is equal to r sin theta are called polar coordinate. Area in polar coordinates. Find area enclosed by the implied by the landscape, r square is equal to 4 cos 2 theta. So area, formula for area is integration 0 to pi by 4, r runs from 0 to root 4 cos 2 theta r dr d theta. 4 times first quadrant. So r is what? Root 4 cos 2 theta. So r runs from 0 to 4 cos theta, and 0 to pi by 4, and 4 times because it is only the first quadrant. So actually these are the important example, double integration, that is x is r cos theta and y is r sin theta. And then in this case dx dy is replaced by mod j. Actually mod j is what? If x is r cos theta and y is r sin theta, mod j is r. So r dr d theta, dx dy replaced. And so when we use these polar coordinates, if there is term x square plus y square, like that term, so evaluate this integration. So integrating with respect to y first, we have this answer 4 by 3. This is by changing the variable. Changing the order of integration. Same example, by changing the order of integration. So this is straightforward. With respect to y first, then with respect to x, we have the answer 4 by 3. If we change the order, if I have to change the order, then what do we have to do? The first draw the figure. So y is equal to 0 means x axis. Then y is equal to x is this line that divides the first plane, first quadrant in two equal parts, makes an 45 angle with x axis and y axis. Then y is equal to 0 means x axis, y is equal to 0 means x axis. Here is x is equal to 0 means y axis, and x is equal to 2. X is equal to 2 is the line, x is equal to 2 is this line, x is equal to 2. Okay, here is not pi, x is equal to 2. And then take a strip parallel to, it is not pi, it is 2. Then take strip parallel to, in order to, now we have to change the order with respect to, we have to integrate with respect to x first. So take a strip parallel to x axis, like this, horizontal strip. And then one end of this strip, that then y, write y dy dx as y dx dy. That is, we have to integrate first with respect to x, that's right. There is no change in the integrand, then there is no change in this function y as it is. And then change the order, dx dy, instead of dy dx, write dx dy. And then one end of this strip touches to the line y is equal to x. So from this, x runs from x lower limit of x is y, and the upper limit is x is equal to 2 is the upper limit. And in order to cover this region, we have to move this strip from this point to this point. That is, at this point y is 0, and at this point y is 2. And then we have the same answer. And the same problem by changing the polar coordinate. That is, substitute x as cos r cos theta, y as r sin theta, then dx dy is r dr d theta. When x is 0, r is 0. And when x is 2, then r is what? 2 r cos theta. That is, r is 2 by cos theta. That is 2 sec theta. And so the limit of r 0 to 2 cos theta, and limit when y is 0, theta is 0. When y is x, when y is 0, then theta is 0. And when y is x, then what do we have? X is r, x is what? When y is x, then r sin theta is equal to r cos theta, means tan theta is equal to, so r get cancelled, tan sin theta by cos theta, tan theta is 1, it means theta is pi by 4. And so limit integration 0 to 2, 0 to x, y dx converted to 0 to pi by 4, 0 to pi by 4. Theta runs from 0 to pi by 4, because from y is equal to x, we have theta is pi by 4. And r runs from 0 to 2 sec theta. R, the value of y is what? R, y is what? R sin theta. And then dy dx is replaced by r dr d theta. And then we have the answer again, same 4 by 3. So the same example by changing the order of straightforward, that is without changing order, answer is 4 by 3. After changing the order, we have the answer 4 by 3. And then using polar coordinate, the same answer is, we have the same answer, that 4 by 3 is the answer. Okay, so we'll see the remaining example in the next lecture.